Now we're going to move on to a new topic, functions. In this video, I will briefly explain what a function is. In the several videos after, I will elaborate more on it. So in algebra, you would use x to represent anything. So you would say, well, if you get anything, and then blah 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 here, it would do this thing here. Well, with functions are the same thing, but with graphs. So you could say, if you get any graph, but the only condition on the graph is that the graph cannot go back on itself. So functions like any graph, you can give me any graph, but the condition that I place on the graph is that it cannot go back on itself. You see, this here is a function, okay, because it doesn't go back on itself. Now this here, hang on, let me give you an example here. You see, this here is not a function because here all is good up to here, but then it goes back on itself here. So this is not a function. This here is a function because it doesn't. Suppose you have a graph that looks like this. This is a function because the graph doesn't go back on itself. For example, if you select, let's say x to be minus 33 here, it would take you to 1 point and only 1 point. If you select, let's say, x to be 0, then it would take you to this point and only 1 point. If you select x to be 73, and it would take you only 1 point. Whereas if you get given something like this here, you see, this is not a function because suppose you select, let's say, a here. Well, it would take you to here, or it would take you to here, or it would take you to here. So you've got three. Well, this is not a function. Well, you can normally test a function by drawing a vertical line. Select any point, and then if it can only have one point here. Well, here you've got three. So that's not a function. If you have something like this, you see, this is a function because there doesn't exist a vertical line where it will give you two values. Here it will give you one. Suppose you have a vertical line here. Can you find a vertical line that will give you more than one value here? No, you can't. So this here is a function because no matter where you select along the x-axis, it will only take you to one. Suppose it's b here. So b here, it will take you to 1. Suppose it's here, it would take you to here. So there's only it will only take you to one value. So for example, you see this here is a function. Let's say so here you're saying, oh, I've got a graph, I've got a function. Here you're saying I've got a function, or you can think of it, I've got a graph that is let's say x squared minus 2. So you see, it will look like this. You see, this here is a function because no matter what value of x you select, let's say b here, okay, suppose you choose b. If you put b into this thing here, f of b will take you to here, and it will only take you to 1 point. If you select, let's say a here, if you put a into here, it will only take you to 1 point. But if you have a function where you have f of x, you see this is not a function, so we can't really use f of, well, we can't even, suppose you have something like this, square root of x here. If you plot this, it will look something like this, okay, because let's select 9 here, okay. If you put 9 into here, you're saying square root of 9. Well, the square root of 9 could be a 3 times a 3, or it could be minus 3. You see, square root of 9 can be it could be minus 3 or 3. So this here could be 3, okay, or it could be minus 3, or it could be minus 3. You see, here if you draw a vertical line here, you're going to have 2 points. So this here is not a function. Most things are functions. So for example, f of x equals, let's say, x squared plus 7, or x to the power of 3. You see, x to the power of 3 well, this graph here will look something like this. You see, no matter what pound, it will look, it's like this, but then it gets shifted up. So maybe it will look something like this. Okay. You see, no matter what, if you draw a vertical line, it will only take you to one point and only one point. So you could say f of x here, hang on, x to the power 3 plus 7. You see, this here is a function. Okay. And the reason why we use functions is because later on we can say, well, if you get one function and then add another function, let's say g of x here. This is why we use a notion of function. It's saying if you get any graph, and then you add another graph, it's like us being able to use x and y here, because it's saying get any number, add another number. Well, here we're saying get any graph, but the condition placed on this, because I said it has to be a function, get any graph that doesn't go back on itself. That's what it's saying. And then add another graph that doesn't go back on itself, and then blah 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 blah. You can do lots of things. So well, just remember that a function is like a graph that doesn't go back on itself. And there are, well, I will explain more on it another time. Okay.